Okay, you should have just received your calendar, and so front of it looks like this, back, go like the back here. You can see today, the first day, we're doing 8-1, finding angle measures and polygons. And the learning target then is I will be able to find angle measures and polygons. So, what's a polygon? Well, remember we've got hexagons, octagons, nonagons, we've got all these different things. So, first off, we're assuming that you know all the different kinds of polygons. So that's a big thing, first off. So if you don't, you're going to have to look up polygons, number of sides, make sure you know things like a hexagon has 6 sides, a octagon has 8 sides, all those good things. There's some really cool stuff in the book with this that kind of makes you think. And so if you think about when we talked about angles inside of polygons before, the one that we've talked about the most is triangles. And triangles have, 3 interior angles, and they have 3 sides, and we know that the angles add up to 180 degrees. Okay. Like I said, the book has some cool stuff and shows you ways to think about this then, and talks about the diagonals, like here, says in a polygon, 2 vertices that are endpoints of the same side are called consecutive vertices. A diagonal of a polygon is a segment that joins 2 non-consecutive vertices. So what they're saying here is like, I can cut some diagonals in here, and then think about this. If I make a diagonal in there, then I've got 1, 2, 3 triangles. And we are just talking about interior angles because even though this one gets split up, it's part of the interior angle on the other part. And so this is 5-sided thing, so a pentagon. And I can figure out pretty quickly then how many degrees the interior angles are going to add up to in a pentagon. Because this has got to be 180, this has got to be 180, this has got to be 180. So if I do 180 plus 180 plus 180, I'm going to get 540. So these all, so angle A, B, C, D, and E, all of them add up to 540 degrees. So similarly, okay, so think what we know so far though. Then we know a triangle, interior angles, sum is 180 degrees. Okay, we know a pentagon, interior angles, sum is 540. Let's do the one in between. So how about like a quadrilateral, something that's got 4 sides. Think about how you can break that one up. Let's just go like this. We've got 2 triangles then. This one, the interior angles are going to be 180, this one 180. So 180 plus 180, the quadrilateral then, the interior angles are going to add up to 360. So think about that. There's kind of a pattern here. And we keep going forever, but think about the pattern then. So if you've got 3 sides, interior angles add up to 180, 4 sides, 360, 5 sides, 540. What do you suppose 6 sides is going to add up to? So I bet some of us see the pattern. So we're adding 180 degrees each time. So next one's 720, next one is 900, and so on and so forth. So there's got to be like an equation we can get out of this having to do with the 180. And if you think about it, we want 1 180 for here, we want 2 180s for here, we want 3 180s for here, we want 4 180s for here, we want 5. So look at what the relationship is there. 3 sides, so this was the sides, sum of interior angles, and this is how many 180 degrees we needed. So sides in this, there's 2 between those every single time. So you just discovered this formula they talked about with me, I guess. They talk about right here in the middle, and I'm on page 507 if you didn't find this. I don't remember if I said that at the beginning or not. The sum of the measures of interior angle of a convex n-gon, so any polygon, n is just the number of sides, is n minus 2 times 180. N is the number of sides or the number of angles. Same thing. So that's a really cool thing. That's really, really helpful. So again, n minus 2 times 180. So let's do some problems that have to do with that. Let's see what we can do here. So I turned the page, now I'm on 508. Let's do these guided practice problems here in the middle. Zoom in just a little bit. So number 1 says, the coin shown is in the shape of a regular 11 gun. Find the sum of the measures of the interior angles. So that's exactly that formula then. Okay, so I know that the formula n minus 2 times 180 is going to work every single time. So this is an 11 gun, so it's got 11 sides or 11 angles. I'm just plugging in 11 right here. Okay, so I'm going to do 11 minus 2 times 180, or in other words, 9 times 180. Okay, and I should know that, but I don't. So 9 times 180 is 1,620 degrees. Okay, so that's the sum of all the interior angles of that 11 gun. So this angle plus this angle plus this angle all the way around. Okay, so that's the sum of those. Number 2, it says the sum of the measures of the interior angles of a convex polygon is 1,440 degrees. Classify the polygon by the number of sides. So now we're just going in reverse, basically. Okay, think about it. They're giving you the answer. They want to know the number of sides. So we're still using our n minus 2 times 180. We just know it's supposed to equal 1,440 degrees in the end. Okay, and there's 2 different ways to do this. You could go ahead and distribute if you wanted to, but what would make it quicker? I can just divide by the 180. That's going to make it quicker. So then I've got n minus 2, 1440 divided by 180. I've got 8. And then add 2 to both sides. And I haven't quite answered the question yet. The question says, classify the polygon by the number of sides. So this is what I was talking about at the beginning. If you don't know what a 10-sided thing is called, you need to make sure you go back and memorize those, because those are things we've talked about a long time ago in junior high and elementary school. So 10 sides is a decagon. Okay, so if you just tell me n equals 10, you're not quite there yet, but you're on the right track. Okay, let's go down to the bottom of the page here. Bottom of the page says, use the diagram at the right, find measure of angle S and measure of angle T. So we've got this diagram over here, and notice what they have written. They have, or not written, but shown, that these 2 angles are congruent to each other. So let's give them a variable then. They're the same thing. They're x. And if I think about how I'm going to solve that then, I first have to know, if I want to make an equation and say, hey, I'm going to add all these up, like, what are they supposed to add up to? Okay, and that's the big part of this. So, let's see if I can squeeze my paper underneath there so you guys can see what I'm thinking. So first off, I've got to know, what is this? Or in other words, how many angles am I talking about, or how many sides? Same thing. Well, I've got 1, 2, 3, 4, 5. So 5 minus 2 times 180 will tell me what they all should add up to. And so 3 times 180. In the end, they should add up to 540 degrees because it's a pentagon. Then I can do my problem. So I know I'm going to then say, okay, this plus this plus this, all 5 things, is supposed to equal 540. But I had to know, like, I had to do that other part first, because otherwise I don't even know what I'm trying to get to. Okay, I can't really write an equation unless I have all the parts. So again, from here it's just solving an equation. Then they're supposed to add up to 540, so go from there. X plus x is 2x. 85 plus 156 plus 93 is 334 equals 540, so minus 334. So 206 divided by 2, so x is 103 degrees, and so that's the measure of angle T and the measure of, I'm sorry, I didn't realize you couldn't quite see that anymore. Scoot it over a little bit. So measure of angle T is 130 degrees, measure of angle S is 130 degrees. Because they were the same thing. So again, the biggest part of that is knowing what they add up to. I've got to do this part over here first to decide what do they add up to even. Okay, next problem, pretty similar, number 4 of the guided practice. says the measures of 3 of the interior angles of a quadrilateral are 89 degrees, 110 degrees, and 46 degrees. Find the measure of the 4th interior angle. So again, I have to know what they're going to add up to in the end anyway. Like I have to figure out what are these even going to add up to. It's a quadrilateral. How many sides does a quadrilateral have? Or how many angles? It has 4. So 4 minus 2 times 180. 2 times 180. We know that we're looking at 360 degrees. Okay. And then I can use that equation again. So I know I've got 4 angles here. I want to find the 4th one, so the 4th one we're going to call x, since we don't know what it is, plus 89 plus 110 plus 46 equals 360. And then just solve from there. So my calculator, 89 plus 110 plus 46 is 245. Subtract that over and we should have our answer. So about 115 degrees. Not about, exactly 115 degrees for that 4th angle. Okay, so that's all the stuff with the sum of the interior angles, and I hope that sounds okay. The second part has to do with the exterior angles. So exterior angles are kind of a weird thing of what we even mean, but if you look over here on the next page, it talks about the exterior angles and kind of shows you what they're saying. So it says, unlike the sum of the interior angles, measures of a convex polygon, the sum of the exterior angles does not depend on the number of sides of the polygon. And these diagrams below suggest that, and then it's kind of cool when you think about it. So the exterior angles are the ones like on the outside. There's one at each vertex. And if you like literally cut those out, that's what they're showing here. If I like cut that out, and I take them and I cut them all out, and then I push them all together, it makes a circle in the end. Okay, and we could do this, it'd be kind of cool. Makes a circle, so then I know it's got to be 360 degrees every time. Doesn't matter how many I have, it's always going to be 360 degrees. So that leads to this theorem now that the exterior angles of any convex polygon are 360 degrees. So it doesn't matter if I've got 5, 10, 3, whatever. They're going to have 360 degrees every single time. Okay, so bottom of the page then, we've got a guided practice problem to make sure we understand that. It says a convex hexagon has exterior angles of measure 34, 49, 58, 67, and 75. What's the measure of an exterior angle at the 6th vertex? Because remember, a hexagon has 6 sides. So think about what we've got to do there. Okay. Again, we know what they all add up to because every single time we see exterior angles, they should add up to 360. So in this case, there's one missing, plus 34, plus 49, plus 58, plus 67, plus 75, and it's got to add up to 360 because we're talking about exterior angles. So again, use a calculator, 34 plus 49, plus 58, plus 67, plus 75. X plus 283 equals 360 minus 283. We've got 77 degrees for that exterior angle. Okay, if we flip the page here, I want to show you a couple more things just so we don't get confused. So in your homework, you can see that there's this whole section up here. You really have to pay attention because things like 11, 12, and 13, those are interior angles. So for stuff like that, I've got to do n minus 2 times 180 first to see what they even add up to. Stuff like 14, 15, and 16 are exterior angles. So I know they're going to add 360 no matter what. So like in 14, I do x plus 65 plus 106 plus 78 equals 360, just like we did on the last problem. 16, same thing. I'd add up all these. And so the x plus x obviously is going to be 2x plus whatever all this adds up to equals 360. Okay, for the exterior angles, doesn't matter. Always adds up to 360. And we're going to do one more problem, number 20, just so that we have an example kind of like that. So number 20 says, find the measure of an interior angle and an exterior angle of the indicated regular polygon. So the word "and" is what I'm worried about. So what I mean is like one. What is one interior angle? What is one exterior angle? Okay, and paper up here so that we can look at it at the same time. So if you think about that, if we're talking about the interior angle, so this is number 20 and I'm on page 511, I can find the sum of the interior angles pretty quickly for this one. I know my formula, n minus 2 times 180. So in this case, 18 gone, so 18 minus 2 times 180, or in other words, 16 times 180. And if I do 16 times 180 in a calculator really quickly, I get 2,880. Okay, but that's not what it asked for. It said, what is the measure of an interior angle? So in other words, what's one interior angle? So think about that. I know all the interior angles are 2,880. I know I'm talking about a regular 18 gun, so if it's a regular 18 gun, how many angles do I have? I've got 18, and if it's regular, they're all the same. So since they're all the same, I can take the 2,880 degrees and divide by 18, and that should give me one interior angle. So one interior angle is 160 degrees. Each of them would be. Okay, so what about the exterior angles? Well, so I know that the sum of the exterior angles is always the same. It's always 360. So this should be a little bit easier then. If I know it's always 360, then, and I know that they're all going to be the same because it's a regular 18 gun, I've just got to do 360 divided by 18 to find one exterior angle. Okay, and that's going to be 20 degrees. And that one's not quite as much work. Now, the one reason we did this is, what's the relationship between those two things? And you should have noticed it up in some of the pictures anyway. Like, what's the relationship there? 160 and 20. I hope you're thinking in your mind, those are supplementary. Because they will be every single time. They're always going to be supplementary. Okay, if you look back up at some of these problems, like where we got the exterior angle shown, what is this angle here? It's got to be 130. They've got to be supplementary because I've got this linear pair going on. You know, any of these would be supplementary. So if I've got these regular things going on, regular 18 gone, or when you do 19 it'll be regular pentagon, and when you do 21 regular supplementary. So here's a quicker way to do this problem then. Which one was easier to find? The sum of the, or the one interior angle or the one exterior angle? The one exterior angle, because for the interior ones, I had to find the whole sum and then divide. So couldn't I have found, think about this faster way, couldn't I have found the one exterior angle first pretty quickly, just dividing 360 by 18? And then since I knew it was supplementary to the interior angle, once I found that 20, couldn't I have just done 180 minus 20 and gotten to the 160 a lot faster? The answer is yes. So knowing those relationships is really, really important. Okay. So that's all I have for you today, just interior angles, exterior angles, regular polygons, irregular polygons, but finding the interior and exterior angles. Biggest thing is make sure you know your polygons, how to classify them. Okay, so again, that's the one thing you might need to look up if you're not sure about like how many sides does a heptagon have, or the number of sides or angles of 7 means heptagon. That's what that word is. Remember, once you get past 10, you can just start using 11 gon, 12 gon, 13 gon, 14 gon. There are special names for those, but it's fine to start using those. Again, your homework is on this page 510, 3 through 15 on, 19, 21, 24, 25, and 29. So go ahead and start working on that now, and hopefully you can get it done in class. Otherwise, have it for me by Wednesday. Thanks.